I want you guys to feel comfortable. I'm just doing this for people who might be absent. So we're recording. These are our overnight cultures. Look how cloudy they are. They look wonderful. That means you grew your recombinant E. coli to saturation. Logarithmic phase took hold and we grew these greatly. They all look really good. Let's do a rudimentary check to see how good these have grown. Let's go. I'm gonna get creative here with the cam. Okay. So one quick way we can check, and this is Rutgers as a way to check, is by putting your cultures in front of black text. If you can see the writing, they're not grown to saturation. Can you guys see the writing?
No.
Well said. No. Let's check the middle two. Can anybody see the writing?
No.
No. Negatory. Niet. Can anybody see the writing?
No.
No. Very good. So they're grown to saturation. Now, what's a better way we could do this? We could take a little bit. We could take a little bit of this sample and put it in a spectrophotometer and check for optical density. We could do that. And that would tell us how many cells we have per unit volume. But if we do that, you know, we're subjecting this to new pipettes, new means to remove cells, and therefore contamination. So honestly, if it's grown like this, it's probably fine. There's probably enough cells. So let's label some new tubes so we can look at these cells. I'm going to call this tube P12T1. P12T1. And I'll call this tube P12T2. And I'll call this tube P12T3. And I'll call this one P12T4. And of course, this one, take a guess. Yep, you were right, P12T5. And lastly, this one, P12T6. Oh my goodness. There's a reason you guys are in AP. Look at that, P12T6. You read my mind. All right, so now we have our, what do we have so far? We have our culture tubes, boom, 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 boom. And we have these new sterile tubes behind them that we're going to put these cells from the culture tubes into. I want to see how many cells, or what's the quantity of cells I have in these cultures. How do we do that? We're going to spin them down. This is called a spin-down step. A spin-down step. Let's do it. So I just happen to have my baby centrifuge over here. Now, why is it a baby? Because it's cute. It's diminutive. It's micro. Now, the only negative thing about this is that it doesn't spin that fast. It spins, I think, like 5,600 RPMs. Now, that's pretty fast, yeah. It's about half the speed of a motorcycle engine, a racing motorcycle engine. About a good, you know, almost about as much of a car engine. Not that fast, though. We want, the ones I have at school, it spins double that speed. Yeah, over double, really. But you know what? This works anyway. It works. It's amazing. Why? Because cells are actually fairly big. They're actually fairly big. And we don't need amazing speeds to separate them. So here we go. Let's do T1 first. T1, T1. Remember the pinky technique? I better not spill it because my computer's right here. So I'm pouring all the liquid. Well, not all of it, almost all of it. I'm leaving a tiny bit behind for a later experiment I'll talk about later. And I'm leaving a tiny bit behind in my culture tube. See, it's just about empty, not totally empty. And I'm gonna
Mr. Jones,
cap this up. Yes, sir.
Won't the cells like kind of sink towards the bottom then?
That's what I want. And I'm going.
You're leaving like the bottom part in the tube.
Oh, these?
Yeah.
Yes. I forgot to show you, but I just shook these a little bit. I did it out of frame. Very good question. Yeah, very good question. I'll show you again. I didn't show you, but I'll show you right now. So here's P12T2. This is empty. P12T2 with my crazy handwriting on it. And let me find P12T2. Here it is. I gotta relabel this thing. This is garbage writing, Jonesy. All right, relabeled. So what was just asked by, who was that? Daniel, I think. He said, wouldn't these cells normally just fall to the bottom? And he's right. So what I do is something called, I'll show you in frame. Actually, can I even show you here? I'll just show you like this. What I do is I do what's called rub it on a rack. I go like this. Really, it's just going like this. You just shake it a bit. It's the same thing. Rub it on a rack is just fun because it's nice and loud. But if you just shake it a bit, it's fine. Getting some feedback on my speakers here. Pouring it over. Closing it. Putting this back. Notice I never put the cap down. I make sure this is on nice and tight. Close this, and this goes in here. All right, number 3, P3T3. P3T3. Give it a little swirl. Show you in frame. Pour it over. Cap it, because we're going to use this later. This gets capped. Put it in the microcentrifuge. P12T4. Swirl it a bit. Pour T12T4 into the microfuge tube. Put the cap back on. Cap that up. Oops. Make sure both caps are on nice and tightly. Nice and tight. That little boy goes in there. P12T5. Cap comes off. Cap comes off. Fill that up. Back on. Back on. And lastly, P12T6. Swirl. Cap comes off. Fill it up. Now this looks empty. This blue cap tube looks empty. It's not. There's a tiny, tiny bit. We're talking probably 10, 15 microliters. It's enough for our ladder experiment. All right. So just FYI, I do have cells in here still. They're still there. All right. So these are, I still have these. I'm going to make sure these are all capped. Cap, 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 smush, cap, smush. Keep these caps smushed on because I don't want these cultures to dehydrate. The remaining culture, I want to keep them for PCR later. All right. I'm going to keep these. These are done though for now. Most of our cells, guys, are in here. Most of our cells are in here. Whee! And we are going to spin this at 5,000 plus RPM to pellet the cells. Let's do it. Press the button. And there it goes. Can you hear it? It's moving. All right, while that's spinning, for a minute, I'm going to get from my mini prep kit made by GE. They're not paying me or anything. I'm just letting you know, made by GE. They used to sponsor the Boxman program. I don't think they do any longer, so perhaps you should, GE, if you're watching. Anyway, this is called a mini prep kit, and I'm going to use solution 1. There's a Roman numeral 1 on it, solution 1. And solution 1, put it right there. Solution 1 is isotonic to the cells. What does that mean?
It has the same concentration.
What does that mean, isotonic to the cells?
I think it's the same solute concentration as the cells.
What does isotonic mean? Do you guys remember what isotonic means?
Wait, remember us?
The quantity of solute to solvent. So there's more solute than solvent.
Ship, hello? Oh, hold on. I couldn't hear you, Siobhan. I couldn't. For some reason, my aux was unplugged. What is Thank you for the comment. What does isotonic mean, Siobhan?
It's the quantity of solute versus solvent. So there would be equal concentrations of solute and solvent here.
There we go. Nice. Yeah, so the solutes and the solvents are equal in these cells that we're going to see in a minute and the solution. So that's good. So that means the cells will not shrink, crenate, nor will they burst, cytolyse. They'll be happy. All right, secondly, this solution, solution 1, also has a weak acid in it called EDTA. And what that does is it chelates, C-H-E-L-A-T-E-S. It chelates. I'm going to write that on the screen. Cool, I can write on the video. C-H-E-L-A-T-E-S. It chelates positive ions, cations. And there's one positive ion, a magnesium ions, in these cells that the cell normally sequesters. And then if they get loose out of the cell, which they will eventually, because we're going to pop these cells, if they get loose, they could activate DNases, and that will destroy the DNA. It'll cut the DNA in the same way RNases do. So the EDTA chelates mean it binds to the magnesium and traps it so that the magnesium doesn't activate DNases. Pretty cool. Interestingly, if you ever ingest heavy metals, let's hope you never do. Mercury, lead, heavy metals, one kind of therapy you might be given by your physician is chelation therapy. Chelation therapy does the same thing. It binds with those heavy metals and then traps them so you can excrete them in different ways. Either your biliary system, your urine, which might not be possible, or plasmapheresis where you can filter your blood out. So the point here is that it chelates them. I think we've spun long enough, haven't we? I think we have. I don't want to overspin them. I can hear them. They're crying. Stop spinning me. You guys hear that? Stop spinning. Okay, I'll stop. Okay, they didn't want to be spun anymore. They told me. I went over there the minute. So let's take these cells and add to them solution 1. So I'll take my pipetter. I'm going to dial it to just under 200. I have it 180. The mini prep kit calls for 175. Rutgers likes 200. I'm going to meet him. I'll do 190. Now I have to be pretty close. I can't overshoot it too much. I can't undershoot it too much. As long as I'm pretty close. I'm kind of going in halfway between Rutgers and what the mini prep directions call for. So that's a fresh, brand new P1000 tip. This is a P1000. It goes to 1000. And I'm dialed to just under 200. And here's the solution one. Okay. I'm going to put my solution one over here. I'm going to vacuum up 200. Now, interestingly, when you pipette, it's really important to bring the things close. You can't see my face, but my face is wicked close to this tip because I want to look at the tip and make sure that I have what I have. Too often, people blind pipette. They don't look at what they're doing. It's really important to look at it. I can't emphasize that enough. So I'm going to take these out of order. It doesn't really matter because we're all getting the same treatment. Hey, it's number one. Actually, you know what? Oh my goodness, I almost skipped a step. Okay, hold the phone. Jonesy almost skipped a step. I'm glad I caught myself. Okay, here's my dump bucket. I have to get rid of liquid first. So I open up my microfuge tube and I dump in my liquid. And I see a cell pellet. See that cell pellet? Can you guys see that? I think you can, right?
Yeah.
That white thing, that's the cell pellet. That's trillions of cells. Easily trillions. Trillions is the highest number I know. So I'm going to say it's trillions. And then here's another one. Let's look at P4. I'm dumping it. Hold on. I'm trying to do this so you can see it. Dumping it. And look at the pellet. Lots of cells. Let's do the next one. T6. Dumping it. Look at the pellet. Now you guys might go, wait a minute, there's some liquid in there still. You're right, there is. I don't want to dump it out too hard because if I do the pellet, I'll lose the pellet. And the pellet is everything. The pellet's my cell mass. I don't want to lose those cells. So I'll sacrifice a little impurity with some food left over in there. Dump out the liquid. But I'll tell you, the bacterial pellet is really sticky. Bacteria is really sticky. There it is.
Still alive?
They're still alive, true. Absolutely alive. Bacteria is super sticky because of a glycocalyx. Very good question, Alex. That was Alex, right? No, it was David. I'm sorry. David. Very good question, David. They're definitely still alive.
Are you gonna kill the bacteria for the get their DNA?
We are. We have to. We're gonna pop them. Pour out the food. Yeah.
Bacteria.
Yeah. We're gonna kill them. There's that pellet. And one more. T2. I think one more. Pour out the food. Liquid. Look at that pellet. Every single table has a nice pellet. I'm going to spin this around and look. You've all got, ooh, this one has a little too much liquid still. This one, a little too much too. You know, the liquid settles. And this one too. I'm just double checking to make sure I got a little liquid. And that pellet's still there, nice and sticky. So I'm looking at them all. They all look pretty good. There's a pellet there, good. I can get rid of a little extra here. All right, those look great. Done. Okay. Gloves are a little nasty. I'm going to switch the gloves. I don't want to contaminate. Even though all of our DNA is down in these, I still, the risk of contamination is low. I still don't want to get any bacterial food on my apparatus here. All right, so new gloves. Here we go. Now we go back to the mini prep step. The first step, solution one. Back to it. So I'm going to vacuum up 200 of my solution one. take my first tube. It doesn't matter the order. It just happens to be 1 again. What luck. I'm going to open the top. Try to put this in the camera frame so you guys can see. It's 1:38 already? Oh my goodness. Wow. Wait a minute. Okay, yeah, we're okay. I'm going to put this solution into the pellet and go up and down. Up and down, up and down, up and down. You see that? So what I'm doing is I'm moving this up and down, mixing the cells in solution 1, vortexing them. They call it vortexing. It's really mixing. You know, it's not a vortex necessarily. I guess it is eventually. It does start spinning. It is called vortexing, but it's just always one. It's really mixing. How do I know I'm done? When I get a bacterial milkshake. Look at that. It looks like it's not milk, trust me. It's a bacterial homogeneous solution. Really, colloid. Really? It's fully uniform. I'm going to put that to the side. Get rid of that tip, that pipette tip. Get a new tip. New solution. This is all new solution, guys. This is all new solution. New tip, new solution. And this is T2.
Mr. Jones, what solution are you putting inside, like into the cell pellet? Is it like some kind of like buffer?
So this is a salt buffer of EDTA, glucose, tris, isotonic to these cells. Can you guys see it going up and down?
Yeah.
Nice. It's isotonic to the cells. It chelates harmful ions. And it's a preservative because I'm going to freeze these tonight until I can get to JP Stevens and do the next steps. I got rid of that tip. I'm getting a new tip, fresh, solution 1. T5. I want T3, don't I? Here we go. Here's T3. Here's T3. I'm adding the solution 1 to T3. I'm going up and down, up and down, up and down, up and down, up and down. Just mixing it. It's called vortexing. I can hear it. Aerating it. I'm making a bacterial milkshake. Look at that. That is homogeneous. That's what we want. Put that back. Get rid of that tip because I'm working with cells and I cannot contaminate. If I cross-contaminate, it's over. New tip. New solution. I'm doing P4 now. T4, excuse me, T4, table 4. Up and down, 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 up and down. Vortex, vortex, vortex. And look at that, nice and homogeneous, great. Just to show you what I'm doing over here. See, I'm getting a new tip. New tip, really, really important. New solution. Really, really important. Let's get 5. That's 5. Luck of the draw. Add those to the cells. Up and down. I'm just going up and down the pipetter. And I'm shooting in air and vacuuming up solution. Shooting out air, vacuuming up solution over and over and over again, like 50 times. until I like the way what I see, and I see it's homogeneous. Shake it off. Shake, shake, shake it off. Like that song, right? I stay out too late. Eating chocolate cake. That's what people say. Shake it off. That's how it goes, right?
Yeah, yeah.
That's how I knew it. I knew that's how it goes.
Actually, not chocolate cake, but you got the melody correct.
I think it's chocolate cake. Vacuum up my 100. I stay out too late. Eating chocolate cake. That's what my friends say. That's what people say. Something like that. Pretty
You're so funny, Mr. Jones.
So we go up and down, 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 vortex, 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 mixing these cells up in this tris EDTA glucose solution so they're nice and happy. They're in an isotonic environment. We're going to freeze them though. I'm sorry, cells. We are going to freeze you. And then we're going to burst you open. But at least enjoy this glucose until we do that. Look at that, homogeneous. All right, homogeneous. Now I get rid of that tip. I use 6 tips. I'm actually looking at my garbage can. I count 6 tips. So that's good because we have 6 tubes. You know, because if I had 5 tips, I'd be like, uh-oh, I got 5 tips. I must have used a tip twice, and that's not good. So what are we working with here? Solution 1 is done. Lysis buffer, they call it lysis buffer type 7. It's interesting. They don't tell you what's on it. You have to really look at the materials to see that. They want to keep this a secret because they want to sell more. They don't want me to make my own. So what do we have? We have the remaining cultures with a tiny bit left over. I'll keep those. And we have these new tubes all looking nice and homogeneous. That's what we want. I'm going to freeze those. And we'll keep going with that. That's step 1 of the mini prep process. Step 1. This is called the spin down step. Step 1 of the mini prep process. All right, I'm going to stop the recording.